Close your eyes and picture the endless expanse of the cosmos, where billions of stars twinkle like scattered jewels across a midnight sea. Feel the gentle pull of the universe, vast and mysterious, wrapping around you like a soft, cosmic blanket. Imagine drifting effortlessly among these stars, on a journey far beyond the reaches of our solar system, to places where the rules of life, as we know them, might bend and transform. Tonight, let the weight of the day fall away as we wander together into this celestial wonderland. Among the stars lie distant worlds, exoplanets, circling suns that are not our own. These are planets beyond the familiar, orbiting stars light years away, and some of them hold secrets that tantalize our imagination. Could they cradle life as we know it, or life beyond what we can even dream? As you settle in, let your mind explore these far-off realms where the mysteries of alien life might be quietly waiting to reveal themselves. Where are you joining us from, and what time is it there? Share your corner of the world in the comments below as we begin this serene voyage through the stars. Now turning to the mystery of alien life, let us explore a question that has captivated humanity for generations. What if we are not alone? Across cultures and centuries, the idea of life beyond Earth has sparked endless wonder and curiosity. It raises possibilities that stretch the imagination. What forms could this life take? Where might it exist, and how might it thrive under conditions so different from those we know? For life, as we understand it, certain ingredients are crucial. Water, the universal solvent, is essential, serving as the foundation for the chemistry of life. A stable atmosphere provides a protective shield and a chance to hold vital elements like oxygen or carbon dioxide. Temperatures that are neither too hot nor too cold create environments where liquid water can exist, a key factor in sustaining life. These conditions, simple yet extraordinary, shape our search for worlds that could host life. But what might that life look like? Could it be familiar or entirely alien to our senses? Perhaps microscopic beings swimming in vast alien oceans, or towering organisms adapting to gravity we cannot imagine. As we ponder these questions, the possibilities seem limitless, each one more intriguing than the last. Every distant world invites us to dream, to wonder, and to imagine the infinite ways life might manifest itself in the universe. With such thoughts lingering, let us drift further into this cosmic mystery and uncover how scientists classify these worlds and what makes some of them particularly special. Now turning to the fascinating question of what exoplanets truly are, let us delve into a realm of discovery that has reshaped our understanding of the cosmos. Exoplanets are planets that orbit stars beyond our sun, existing far outside the familiar boundaries of our solar system. While the planets in our own system have been studied for centuries, exoplanets are relatively new to us, with their existence only confirmed in recent decades. What makes these distant worlds so remarkable is their sheer diversity. Some are gas giants, enormous planets composed primarily of hydrogen and helium, resembling our Jupiter, but often much larger or denser. Others are rocky and solid, potentially similar to Earth or Mars, with surfaces that might host mountains, valleys, or even oceans. There are also water worlds, planets that may be almost entirely covered by vast, unbroken seas. Each type offers a unique glimpse into the incredible variety of planetary systems scattered across the galaxy. The first confirmed discovery of an exoplanet was a milestone in human exploration, revealing that our solar system is but one of countless planetary arrangements in the universe. Since then, scientists have uncovered thousands, each with its own story to tell, ranging from blazing hot worlds orbiting perilously close to their stars to frozen orbs drifting in the far reaches of space. The methods used to find these planets, such as observing subtle dips in starlight as a planet passes in front of its star, or measuring the gravitational pull a planet exerts on its star, showcase the ingenuity and determination of astronomers to uncover the unknown. As we uncover this incredible variety, we start to see just how special some of these planets are, worlds that may not only resemble Earth, but could also hold the key ingredients for life. Let us now journey forward and discover how scientists determine which of these extraordinary worlds could truly be habitats for life as we know it. Moving forward, let us explore the captivating concept of the habitable zone, often referred to as the Goldilocks Zone. This is the region around a star where conditions are neither too hot nor too cold, but just right for liquid water to exist, a key ingredient for life as we know it. Imagine a planet orbiting within this delicate balance, where gentle warmth from its star keeps water in a liquid state on its surface, creating a cradle of possibility for life to thrive. The distance of this zone varies depending on the star's size and temperature. For instance, around smaller, cooler stars, the Goldilocks zone sits much closer, while for larger, hotter stars, it lies farther out. Scientists use this criterion as a beacon in their search for habitable worlds, narrowing their focus to planets that fall within these celestial sweet spots. These zones hold the promise of conditions akin to those on Earth, where seas, rivers, and perhaps even ecosystems could flourish. Picture yourself drifting through one of these zones in space, gazing upon worlds that hold the potential for life to emerge. While identifying a planet in the habitable zone is an essential first step, it is only the beginning of the journey. Scientists also consider additional factors, such as the planet's atmosphere, composition, and the presence of essential chemicals, to evaluate its true potential for hosting life. The Goldilocks Zone serves as a reminder of just how finely tuned the requirements for life can be, offering a glimpse into the incredible precision of the cosmos. As we continue, let us turn our attention to some of the most intriguing exoplanets that reside in these habitable zones, each offering its own story and the tantalizing possibility of alien life. Now turning to the next chapter, let us delve into the fascinating variety of exoplanets that dwell within these habitable zones, starting with one that has captured the imagination of scientists and dreamers alike, Kepler 452b, often referred to as Earth's older cousin. Nestled in the habitable zone of a star remarkably similar to our Sun, this exoplanet, it offers a tantalizing glimpse into what an Earth-like world might look like far beyond our solar system. Kepler 452b is larger than Earth, which categorizes it as a super-Earth, and it completes one orbit around its star in about 385 days, making its years surprisingly close in length to our own. Imagine standing on its surface, where the gravity would be noticeably stronger due to its increased size, and the skies might glow with a sunlight eerily familiar, yet slightly warmer in tone. What makes Kepler 452b so intriguing is not just its location in the habitable zone, but also the likelihood of it having rocky terrain and potentially even liquid water. While we do not yet have direct evidence of its atmosphere or surface conditions, scientists view it as a prime candidate for further exploration because of its similarities to Earth and its age, which could allow life to have developed over billions of years. Picture a world where ancient forests sway under the gentle rays of a familiar sun, and where alien life may have taken steps we can only dream of. Kepler 452b serves as a reminder that among the stars, there may be echoes of our home waiting to be discovered. With this thought in mind, let us now journey onward to explore another extraordinary exoplanet, one that presents an entirely different possibility for life. Kepler 22b, a world dominated by water and shrouded in mystery. Now turning to the next chapter, let us dive into the captivating world of Kepler 22b, a planet that stands out as an extraordinarily unique candidate in the search for alien life. Unlike the rocky terrains we associate with Earth and its cousins, Kepler 22b is often described as an ocean world, potentially enveloped by vast, endless seas. Located around 600 light-years away in the habitable zone of its parent star, Kepler 22b is larger than Earth, falling into the category of a super-Earth. Its size hints at a fascinating possibility, a planet where water might not just exist in patches or lakes, but could completely dominate its surface. Imagine a world where waves stretch endlessly to the horizon, a liquid landscape shaped by alien winds and tides. The lack of visible land does not mean the absence of life. Far from it, scientists speculate that such worlds could teem with aquatic ecosystems entirely adapted to this vast oceanic environment. Think of a place where life evolves beneath the waves, drifting in currents or anchored to submerged features that remain hidden from the surface. The planet's orbit around a star, similar to our Sun, allows for a mild climate that could support liquid water over long periods. While we cannot yet picture its marine depths with certainty, Kepler 22b gives wings to our imagination of alien oceans, unlike anything we have seen. Could intelligent life swim through its waters, or might it be home to simpler, thriving organisms floating unobserved? With so many questions surrounding this aquatic mystery, Kepler 22b reminds us of the incredible diversity that exists even within the category of habitable zones. As we let the currents of curiosity guide our thoughts, let us now sail onward to examine Proxima Centauri b, a neighboring planet that brings the search for alien life closer to our own cosmic backyard. Now turning to Proxima Centauri b, we arrive at a destination remarkably close to us in cosmic terms, just over 4 light-years away. Orbiting the red dwarf star, Proxima Centauri, this exoplanet resides within the habitable zone, where conditions might allow liquid water to exist on its surface. Slightly larger than Earth, Proxima Centauri b shares intriguing similarities with our planet, igniting the imagination of scientists and stargazers alike. Picture yourself standing on its surface, a world bathed in the dim, reddish glow of its host star, casting long, soft shadows across the landscape. The weaker sunlight would create an atmosphere of perpetual twilight, painting the sky with hues unknown to Earth. The temperatures, though potentially life-sustaining, might feel cooler than our own, depending on the thickness and composition of its atmosphere, which remains a mystery. Scientists are enthralled by the possibilities here. Could this seemingly tranquil world harbor life forms that have adapted to its unique environment? Or is it a silent, uninhabited sphere waiting for discovery? Its proximity to Earth makes it an enticing candidate for further exploration, and future missions may provide the answers we seek. As we ponder the quiet allure of Proxima Centauri b, let us now shift our focus to the dazzling TRAPPIST-1 system, a wonderland of planets, offering even more insights into the diversity of potential alien worlds. Now turning to Kepler 22b, we venture over 600 light-years away to a world that captivates with its serene and mysterious allure. Known as the ocean world, Kepler 22b is an exoplanet that might be enveloped by an immense liquid ocean, stretching endlessly beneath alien skies. Slightly more than twice the size of Earth, its surface could be a vast, shimmering expanse of water, where waves roll gently under the soft illumination of its host star. Imagine drifting across these otherworldly waters, the horizon melting seamlessly into the sky, a tranquil yet enigmatic realm teeming with possibility. The atmosphere enveloping Kepler 22b remains unknown, but if conditions favor habitability, this ocean could cradle life forms that thrive in ways beyond our imagination. Could there be alien creatures gliding gracefully through its hidden depths, or sprawling ecosystems flourishing in the unseen currents below? The thought of an aquatic biosphere, perhaps more primitive or advanced than Earth's marine life, fuels the curiosity of astronomers and dreamers alike. The planet's moderate temperature, thanks to its location within the habitable zone, adds further intrigue to its potential as a cradle for life. While much about Kepler 22b remains a mystery, its silent beauty and boundless waters inspire both awe and endless questions. From this aquatic wonder, let us now journey to a cosmic neighborhood rich with variety, the TRAPPIST-1 system, a dazzling collection of worlds orbiting a distant star. Now turning to Proxima Centauri b, we arrive at the closest known exoplanet to our solar system, a mere 4 light-years away, a cosmic stone's throw in the vastness of space. Orbiting the faint red dwarf Proxima Centauri, this rocky world has sparked immense curiosity due to its potential for hosting life. Nestled within the habitable zone of its star, Proxima Centauri b could have conditions that allow liquid water to exist on its surface, a critical ingredient for life as we know it. Yet, its environment is far from simple. The planet orbits its dim sun much closer than Earth orbits ours, completing a year in just 11 Earth days. While this proximity places it in the habitable zone, it also exposes the planet to intense stellar flares and radiation from its volatile host star. Despite these challenges, Many wonder if life, perhaps quite different from what we know, might have adapted to thrive in such an environment. Imagine standing on its surface, the sky dominated by a dim, reddish sun, casting an eerie glow over the landscape. The air might be heavy, or perhaps thin, depending on whether Proxima Centauri b has managed to retain an atmosphere. The idea of interstellar missions to this nearby world has captured the imagination of scientists and dreamers alike. Could humanity one day embark on a voyage to explore this enigmatic neighbor, searching for signs of life, or even building a foothold for future generations? The possibilities are as vast as the universe itself. From this intriguing world, let us now set our sights on the TRAPPIST-1 system, a breathtaking collection of planets that form a cosmic wonderland of diversity and potential. Now turning to the TRAPPIST-1 system, we find ourselves amidst a cosmic masterpiece, unlike any other. This ultra-cool red dwarf star, located about 39 light-years away, is home to 7 Earth-sized planets, a rarity in itself. What makes this system truly remarkable is that 3 of these planets reside within the habitable zone, where conditions might allow liquid water to exist. Imagine standing on the surface of one of these worlds, gazing up at a sky filled with neighboring planets, so close that some might appear larger than the moon does from Earth. These planets could reveal themselves as colorful orbs, their surfaces reflecting the faint light of their dim, reddish sun. Each world in this tightly packed system offers its own unique characteristics, from rocky terrains to potential atmospheres that might vary in composition and density. The close proximity of these planets to their host star means they orbit quickly, completing their years in just a few days. Yet, the gentle warmth of TRAPPIST-1 faint glow provides a stable environment, sparking hope that life, perhaps in forms we cannot yet imagine, could have taken root on one or more of these celestial siblings. The diversity within this planetary family increases the odds of finding life, as each world presents a different set of conditions that could support a variety of ecosystems. Scientists are captivated by this system, not only because of its potential for habitability, but also because it allows the study of multiple Earth-sized planets simultaneously, each with its own story to tell. As we marvel at this wonderland of possibilities, one can only dream of the day when we might visit these distant worlds, standing among the stars and unraveling the mysteries they hold. Let us now explore TRAPPIST-1e, one of the most promising candidates within this extraordinary system, often referred to as a second Earth. Now turning to TRAPPIST-1e, we arrive at one of the most intriguing worlds within this extraordinary system. Often hailed as a second Earth, this exoplanet lies comfortably within the habitable zone of its parent star, where temperatures could allow liquid water to flow across its surface. Its Earth-like size and density suggest a rocky composition, and the possibility of a protective atmosphere only adds to the allure of this distant gem. Imagine standing on TRAPPIST-1e itself. The sky above might glow with a gentle reddish hue, illuminated by the soft warmth of its ultra-cool star. Nearby planets could be visible as bright, ethereal shapes, gracing the horizon like celestial companions. The surface might echo with the calm of a world untouched, its landscapes potentially dotted with alien terrains, perhaps rivers winding through plains, or seas gently lapping against shores. Though we cannot yet confirm these details, the mere thought of liquid water, so essential to life as we know it, stirs the imagination. TRAPPIST-1e captures the hopes of scientists worldwide because it offers a tantalizing glimpse into what another Earth might look like, a world that could sustain life in ways we are just beginning to fathom. It serves as a reminder of the boundless potential the universe holds, encouraging us to continue seeking answers among the stars. As we linger on this serene vision of TRAPPIST-1e, our journey beckons us onward to yet another captivating world that promises to reveal even more cosmic secrets. Now turning to K2-18b, we journey to a fascinating super-Earth that has sparked remarkable curiosity among scientists and dreamers alike. This distant world, significantly larger than our own, resides within the habitable zone of its star. What makes K2-18b truly extraordinary is the detection of water vapor in its atmosphere, a discovery that has rekindled hopes in the search for alien life. Water, the cornerstone of life as we know it, hints at the tantalizing potential for habitability on this far-off planet. Imagine standing beneath the skies of K2-18b, where alien clouds might drift gently above, their hues shaped by the chemistry of an atmosphere unlike anything on Earth. These clouds could shimmer with colors unfamiliar, casting shadows over landscapes that lie waiting to be uncovered. The atmosphere here might feel thick, enveloping, and alive with possibilities, as though the very air whispers tales of worlds beyond our comprehension. While we have yet to confirm the existence of surface water, the mere presence of vapor in the skies above indicates a world that could sustain life. It inspires questions of what forms that life might take, how it could adapt to its unique environment, and what secrets it holds. Scientists marvel at the opportunity K2-18b presents, a super-Earth rich with promise and potential. Its allure lies not just in the data we gather, but in the dreams it fuels, a vision of life thriving under skies alien to us, yet bound by the same universal threads. As we ponder the mysterious beauty of K2-18b, it invites us to continue this endless quest, turning our gaze to the stars for answers yet to be revealed. With this sense of awe, we move forward to explore yet more extraordinary worlds waiting to capture our imaginations. Moving forward, we arrive at LHS 1140b, a rocky super-Earth that resides within the habitable zone of its parent star. This dense and resilient planet captures the imaginations of scientists with its intriguing combination of features that suggest it could host life. Enveloped by a thick atmosphere, LHS 1140b provides a stable environment that might shield its surface from the harsh radiation of space. Its gravity, stronger than Earth's, could nurture an atmosphere dense enough to support liquid water, an essential ingredient for life as we understand it. Picture a quiet world bathed in a reddish glow, its skies painted by the light of a cool, dim star. The surface might feel solid and enduring underfoot, a reflection of the planet's immense density. The air could be rich and heavy, carrying stories of a world waiting to be discovered. It is a place where time feels slower, where each moment seems to linger under the calm, persistent light of its celestial companion. Scientists are inspired by the thought of what might thrive here. Perhaps life forms uniquely adapted to the weighty atmosphere and faint red luminescence. LHS 1140b stands as a testament to how diverse conditions across the cosmos offer endless possibilities for life to take root. It encourages us to imagine not just what we might find, but also how resilient life can be under circumstances so different from our own. With this quiet awe, we continue our journey, moving from the steadfast charm of LHS 1140b to explore even more planets that beckon us with their mysteries. Now turning to Gliese 581g, we encounter a planet shrouded in both hope and mystery, often considered one of the most promising candidates for hosting life beyond Earth. Its very existence remains a topic of spirited scientific debate. If confirmed, this enigmatic world would occupy a coveted position within the habitable zone of its star, where conditions might allow liquid water to flow and nurture life. Imagine a planet that, if real, could hold breathtaking landscapes under a dim, ruby-red sky, its surface kissed gently by the glow of a distant star. Gliese 581g stirs the imagination as a place where alien life forms could adapt to its unique environment, evolving under the steady but faint warmth of its celestial host. Yet its story is one of uncertainty, of data that whispers possibilities but stops just shy of certainty. Scientists continue to scrutinize the signals, torn between cautious skepticism and the tantalizing allure of what might be. It is a reminder of how vast our universe is and how even a whisper of potential fuels our quest for discovery. As we step away from the mystery of Gliese 581g, we carry with us a renewed sense of wonder, eager to unravel more cosmic secrets waiting just beyond the veil of the known. Moving forward, we arrive at Gliese 667cc, an intriguing exoplanet nestled within a crowded and dynamic multi-star system. Orbiting one of 3 stars in this fascinating celestial trio, this planet resides comfortably within its star's habitable zone, where conditions could be just right to support liquid water and potentially life. Picture a world where the sky is a mesmerizing tapestry of light, illuminated by the warm, steady glow of its parent star and accented by the distant brilliance of 2 neighboring suns. Such a setting might shape life in ways we can scarcely imagine, fostering adaptations to a sky that never truly darkens. Gliese 667cc captivates scientists, not just for its location, but also for the unique challenges and opportunities provided by its environment. With its proximity to other stars, alien life here might evolve to navigate shifting light patterns, thriving under the interplay of diverse spectral energies. This world reminds us of the boundless creativity that nature could unleash in regions far different from our own. It is a testament to how the universe consistently surprises us, offering possibilities that stretch beyond the limits of our current understanding. With Gliese 667cc sparking our curiosity, we continue our journey, eager to uncover even more wonders that lie hidden among the stars. Now turning to HE 40307g, we find ourselves exploring a super-Earth exoplanet that sits serenely within the habitable zone of its parent star. This planet, larger and more massive than Earth, offers the tantalizing possibility of conditions just right for supporting life as we know it. Imagine a world where gravity pulls a little stronger, giving rise to denser atmospheres and perhaps towering landscapes sculpted over eons. The gentle warmth of its star bathes this planet in a stable, life-sustaining environment, making it one of the most promising candidates for habitability. Scientists are particularly intrigued by its potential for liquid water, a key ingredient for life, which might flow across its surface in sparkling rivers or gather in vast alien oceans. With its position in the habitable zone, HE 40,307 G invites us to dream of lush, unearthly terrains, teeming with life forms that have adapted to its unique conditions. Could the denser air support creatures soaring with ease, or might we find ecosystems thriving beneath tranquil waters? This super-Earth beckons us to imagine the rich possibilities of evolution unfolding in ways we have yet to conceive. As we marvel at the potential of HD 40,307 G, it reminds us how vast and varied the universe truly is. Carrying a sense of wonder, we journey onward to uncover even more extraordinary worlds awaiting discovery. With the next phase of the journey in sight, we find ourselves captivated by the enigmatic PSOJ 318 522, a rogue planet adrift in the vast expanse of space, without the comforting presence of a parent star. This solitary wanderer, untethered and free, floats silently through the cosmos, shrouded in eternal night. Yet even in this profound isolation, scientists ponder the possibilities of life, forming under such unique conditions. Without the warmth of a star, SOJ 318 522 might rely on its own internal heat, generated by lingering geothermal activity, to create pockets of habitability beneath its surface. Imagine an underground world warmed from within, where alien ecosystems could flourish in sheltered environments, shielded from the eternal cold of space. Its atmosphere, if dense enough, could trap heat and nurture bizarre, resilient life forms adapted to complete darkness. Drifting through the endless void, this rogue planet challenges our understanding of what it takes to sustain life, offering a tranquil reminder that nature's creativity knows no bounds. As SOJ 318 522 continues its silent journey, it invites us to reflect on the infinite possibilities hidden within the universe, reminding us that even the loneliest of worlds can harbor secrets waiting to be uncovered. With this in mind, we move onward to explore a new frontier in the search for life, the fascinating concept of exomoons and the potential they hold. Now turning to the fascinating concept of exomoons, we find ourselves exploring a new frontier in the search for life beyond our world. While much of the focus has been on planets orbiting stars in the habitable zone, the moons that accompany these planets may hold equally promising potential for life. These are not unlike the moons within our own solar system, such as Europa and Enceladus, which intrigue scientists with their hidden oceans beneath icy crusts and the possibility of subsurface ecosystems. Imagine for a moment a moon orbiting a massive gas giant within the lush habitable zone of a distant star. Its skies might be a dazzling canvas, filled not only with the brilliance of stars, but also with the striking presence of its parent planet, looming large and radiant. Beneath such a captivating sky, the moon itself could host conditions ripe for life, warmed by tidal forces created by the gravitational pull of its planet. This gentle heating could sustain liquid water beneath its surface, or even on it under the right conditions. Exomoons might even boast diverse landscapes, from vast oceans illuminated by the soft glow of starlight to rugged terrains shaped by volcanic activity. Their atmospheres, if present, could offer essential elements like oxygen or methane, nurturing an alien biosphere. These moons invite endless questions and ignite the imagination. Could their ecosystems mirror the complexity of Earth's, or might they develop along an entirely different path? Just as Europa and Enceladus tantalize us with the prospect of life within our own celestial neighborhood, exomoons across the galaxy may host mysteries yet to be revealed, awaiting the day when humanity's gaze reaches their distant shores. As this captivating vision of exomoons fills our thoughts, we now turn to the sophisticated methods scientists use to discover such wonders and the challenges they face in unveiling the secrets of distant worlds. Moving forward, let us unravel the remarkable techniques scientists employ to discover exoplanets, those distant worlds hidden among the stars. Imagine peering into the vastness of space, where clues to these planets subtly reveal themselves through the dance of light and motion. One such method, known as the transit method, involves observing tiny dimming in a star's brightness. Picture a planet passing directly between its star and our perspective here on Earth, creating a gentle and rhythmic dip in the light we receive. This slight change, though nearly imperceptible, speaks volumes, hinting at the presence of a planet and revealing its size, orbit, and even potential atmosphere. Another method, called radial velocity, listens to the star itself. When a planet orbits a star, their mutual gravitational pull causes the star to wobble ever so slightly. This wobble alters the light waves emitted by the star, stretching and compressing them in a measurable way. By carefully analyzing this light, scientists can deduce the planet's mass and the shape of its orbit, unlocking more secrets of its nature. These techniques are akin to solving a cosmic puzzle, piecing together fragments of data to form a clearer picture of worlds untold. They demand extraordinary precision and innovation, as the signals are often faint and challenging to detect amidst the noise of the universe. Yet, with every discovery, our understanding grows, revealing the incredible diversity of exoplanets. From giant gas planets with swirling atmospheres to rocky Earth-like worlds in the coveted habitable zone, these methods have opened a window into the abundance of planets scattered across the galaxy. As we marvel at the ingenuity behind these discoveries, we prepare to dive deeper into the forms that alien life might take, pondering the infinite possibilities that await us on these distant worlds. Now turning to the possibilities of alien life, let us voyage into the realm of imagination and science to explore what life beyond Earth might truly be like. On some exoplanets, life could take the form of tiny yet resilient microbes, thriving in extreme conditions that would seem inhospitable to us. Picture microscopic organisms clinging to the edges of a boiling volcanic spring, feeding on minerals and light, their very existence a testament to life's adaptability. On worlds with vast oceans like Kepler 22b, alien life might flourish beneath endless waves, perhaps as bioluminescent creatures shimmering in the dark, weaving delicate webs of interaction in a liquid world untouched by sunlight. Meanwhile, on rocky planets with thick atmospheres, imagine towering plant-like structures, absorbing energy from their star or even the chemicals in the air, rooted in a terrain unlike anything we have ever seen. And what of intelligent species? On planets shaped by different gravities and climates, advanced beings could evolve in ways completely unfamiliar to human understanding. Perhaps they communicate through changing colors, vibrations, or electromagnetic pulses. Their societies built not with tools like ours, but through organic or even symbiotic means. Ecosystems, too, might challenge our perception of life, with networks of interdependent species thriving in environments vastly different from Earth's delicate balance. Think of forests that glow in the dark, skies filled with alien birds that glide through dense, multicolored atmospheres, or sprawling plains where life forms adapt in unimaginable ways to survive. Each exoplanet, it offers a blank canvas on which nature could paint a masterpiece entirely unlike our own world. As we consider these thrilling possibilities, let us hold on to the wonder of what might be, knowing that the universe often surprises us in ways we cannot yet comprehend. With this sense of curiosity guiding us, let us now turn our thoughts to the signs and clues that could help us determine if such life exists, delving into the concept of biosignatures and the tools designed to detect them. Now turning to the fascinating concept of biosignatures, we embark on a journey to uncover the subtle clues that could reveal the presence of life beyond Earth. Biosignatures are the chemical, physical, or biological markers that point to the existence of life, past or present. In the context of distant exoplanets, these markers are often found in the makeup of their atmospheres. For example, certain gases like oxygen or methane, when present in specific combinations, may suggest biological activity. Imagine peering through the vastness of space to analyze the light passing through an exoplanet, its atmosphere. By breaking this light into its component colors, scientists can determine the elements and compounds present, much like unraveling a cosmic fingerprint. Tools like the powerful James Webb Space Telescope and other advanced observatories allow astronomers to study these spectral signatures with incredible precision. Picture a future where such tools detect unexpected patterns, an enigmatic mix of gases that could only exist through the influence of living organisms. This would be a monumental discovery, sparking both excitement and profound questions about what forms this alien life might take. Beyond atmospheric analysis, surface features visible on exoplanets could also provide hints. Changes in light reflected off a planet's surface might suggest vegetation like growths or even oceans brimming with organic activity. As researchers refine their techniques, they also look for seasonal changes or repeated patterns that could indicate dynamic ecosystems. The search for biosignatures doesn't only rely on telescopes. Scientists are also exploring new technologies designed to detect these clues, from space-based probes to innovative lab experiments, simulating alien environments. Imagine the moment when humanity first confirms the unmistakable signature of life, perhaps a chemical imbalance in an atmosphere, or a unique reflection of light bouncing off a living surface. What a profound shift it would be to know we are not alone in the tapestry of the universe. With biosignatures guiding us, we edge closer to an answer to one of the most timeless questions, turning now to the incredible role of global space agencies in unraveling these cosmic mysteries. Now turning to the incredible role of global space agencies, we uncover how humanity has rallied its brightest minds to explore the unknown and push the boundaries of what we can achieve together. Central to this effort is NASA, whose missions have revolutionized our understanding of the cosmos. Take the Kepler Space Telescope, for example, a mission that transformed the search for exoplanets by identifying thousands of these distant worlds, many of which are in the habitable zones of their stars. Imagine the excitement as data poured in, revealing planets with potential conditions for life. Building on Kepler's success, newer missions like the James Webb Space Telescope take exploration to even greater heights. This marvel of engineering allows us to peer deeper into the universe with unprecedented clarity, analyzing the atmospheres of exoplanets and searching for those telltale biosignatures. Agencies like the European Space Agency contribute to this monumental quest as well, with missions like Cheops and Plato, dedicated to studying these alien worlds and their potential for habitability. Collaboration across borders and disciplines creates a shared sense of purpose, reminding us that the pursuit of knowledge is a profound and unifying endeavor. Picture the dedication of scientists and engineers working to design and launch these groundbreaking observatories, their collective efforts propelling us closer to unraveling the mysteries of the stars. These agencies not only inspire, but they challenge us to think bigger, to dream of a future where humanity reaches out to distant worlds. As we celebrate their contributions, we also look forward to the next wave of exploration, where technology grows ever more sophisticated and our questions about the universe become even more daring. With each discovery, we strengthen our connection to the cosmos, drawing closer to the answers that lie among the stars. Moving forward, we shift focus to the groundbreaking promise of the James Webb Space Telescope and how it could redefine our search for life beyond Earth. Moving forward, we delve into the groundbreaking promise of the James Webb Space Telescope, a technological marvel that stands at the forefront of humanity's quest to understand the cosmos. Its capabilities far surpass those of its predecessors, offering an unparalleled view of the universe that brings us closer to answering one of humanity's most profound questions. Are we alone in the vast expanse of space? Unlike the telescopes before it, the James Webb Telescope specializes in detecting the faintest glimmers of light from distant worlds, peering into their atmospheres with extraordinary precision. This advanced instrument allows scientists to study the chemical composition of exoplanet atmospheres, searching for vital clues that could signal the presence of life. These signs, known as biosignatures, might include elements like oxygen, methane, or even water vapor, which hint at biological processes similar to those on Earth. Imagine the excitement that would ripple across the globe if such evidence were to be discovered, forever transforming our understanding of life's potential diversity. Beyond identifying biosignatures, the telescope's infrared capabilities enable it to look deeper into the universe than ever before, studying exoplanets orbiting faint stars, including ones in distant regions that were previously beyond our reach. This incredible leap in exploration equips us to scrutinize planets not only for habitability, but also for unique environmental conditions that could host entirely new forms of life. Picture the intricate data being analyzed, revealing layers of information about atmospheric pressures, temperatures, and even weather patterns on these alien worlds. The James Webb Space Telescope truly represents the next chapter in our search for life among the stars, its potential so immense that it could redefine our place in the universe. As we marvel at this engineering triumph, we also turn our thoughts to the possibility of intelligent signals from far-off civilizations, a notion that introduces us to the efforts of the SETI Institute and their search for extraterrestrial intelligence. Now turning to the SETI Institute, an organization at the forefront of humanity's search for intelligent life beyond Earth. Short for the Search for Extraterrestrial Intelligence, the SETI Institute dedicates itself to scanning the cosmos for signals that may originate from advanced alien civilizations. Using an array of sophisticated radio telescopes and data analysis tools, scientists carefully monitor distant stars and planets, listening for patterns or transmissions that stand out from the natural background of the universe. Imagine the profound impact of detecting a deliberate signal crafted by intelligent beings from a world light years away. Such a moment would redefine everything we know about our place in the cosmos, forging a connection that transcends the boundaries of time and space. The idea of contact ignites both scientific curiosity and philosophical reflection as we ponder the nature of these potential civilizations. Are they peaceful explorers like us, or have they traversed challenges we have yet to face? Through this patient and meticulous search, the SETI Institute reminds us of the vast possibilities that lie beyond our understanding, encouraging humanity to dream bigger and think farther. As we listen intently to the stars, we find ourselves not only searching for others, but also uncovering new perspectives on what it means to be human. With the search continuing, we now shift our attention to one of the great cosmic mysteries, the Fermi paradox, which asks a question that lingers in the hearts of many: where is everybody? Now turning to the Fermi paradox, a fascinating and timeless question that challenges us to look deeper into the cosmos and into ourselves. It asks why, in a universe so vast, filled with billions of stars and even more planets, we have yet to find evidence of alien life. The sheer probability suggests we should not be alone, and yet the silence of the universe persists. One possible explanation could be the immense distances between stars, making communication or travel nearly impossible within a human lifetime. Another could be that advanced civilizations inevitably face challenges that lead to their eventual extinction before they can contact others. Some suggest that life itself may be extraordinarily rare, requiring a precise combination of events too unlikely to replicate elsewhere. Others wonder if alien civilizations are deliberately avoiding us, choosing to observe silently or avoid interference altogether. Yet still, there is the intriguing possibility that we are simply looking in the wrong way or in the wrong places, with life existing in forms or environments we cannot yet comprehend or detect. This paradox invites us to question not only the nature of the universe, but also the assumptions we make about life and intelligence. It encourages patience and humility as we continue the search, reminding us that the answers may require a perspective far beyond what we currently possess. As we contemplate this profound mystery, we are reminded that the search for extraterrestrial life is as much about understanding the universe as it is about understanding ourselves. With these thoughts in mind, we move now to explore a mathematical framework that seeks to estimate the number of advanced alien civilizations, known as the Drake equation. With the next phase of the journey in sight, we arrive at the Drake equation, a fascinating tool developed to estimate the number of advanced civilizations that might exist in our galaxy, the Milky Way. Created by the astrophysicist Frank Drake in the early 1960s, this equation combines a series of factors to offer insight into the likelihood of intelligent life beyond Earth. While it cannot provide a definitive answer, it helps us organize our understanding of the factors needed for civilizations to arise and survive. Let us gently unravel its components. The equation begins with the rate at which stars are formed in our galaxy, a number that provides the foundation for everything else. From this, it considers what fraction of those stars have planets. Thanks to modern astronomy, we now know that planets are common, and this percentage is likely quite high. Next, it narrows down to the number of these planets that could potentially host life, focusing on those within the habitable zones of their stars, where conditions may be just right for liquid water. Then, it asks what fraction of these planets actually develop life, a question still steeped in mystery. Following this, it wonders how often life evolves into intelligent beings capable of creating technology that could communicate across the stars. Finally, it factors in the lifespan of such civilizations, how long they remain detectable before they either go silent or cease to exist. Each of these variables involves considerable uncertainty, but together, they provide a structured way to approach the vast unknowns of our galaxy. The beauty of the Drake equation lies not in certainty, but in its ability to inspire curiosity and frame some of life's biggest questions. Through its lens, we are reminded of the incredible complexity required for civilizations to arise and the challenges they must navigate to endure. As we ponder its implications, the equation invites us to dream of the possibilities, urging us to look deeper and think more expansively about what it means to share this universe. With this mathematical framework as our guide, we turn now to examine the challenges of communicating with alien civilizations, a task fraught with mystery, imagination, and the vast distances of space. Moving forward, we delve into the challenges of alien communication, a puzzle as vast and intricate as the cosmos itself. Imagine standing under a starlit sky, sending a message into the infinite expanse, unsure if anyone will ever receive it. The first challenge lies in the sheer distances between us and potential alien civilizations. Even the closest stars are so far away that light, traveling at its incomprehensible speed, takes years to bridge the gap. A message sent today might take decades, centuries, or even millennia to reach a destination, and any response could take just as long to return. Then there is the question of language. How do we communicate with beings who may not share our biology, experiences, or perceptions of existence? Their way of interpreting the universe could be so different that even the simplest ideas might seem unfathomable. Scientists have proposed using mathematics and physics as universal languages, as they represent principles that hold true across the cosmos. But even so, translating abstract equations into meaningful communication remains a daunting task. Time presents another barrier. Civilizations, including our own, rise and fall. The window during which two intelligent species might coexist and be technologically capable of contact could be brief on a cosmic scale. A message might arrive only to find silence, the sender having vanished into history. Despite these challenges, the act of transmitting signals into space is a testament to hope. It is a quiet, patient gesture, a way of saying, "We are here, wondering if you are too." As we send these messages, we also listen, our instruments scanning the heavens for even the faintest sign of acknowledgement. The process is slow and uncertain, yet it embodies the human spirit, curious, persistent, and endlessly fascinated by the unknown. The challenges of alien communication remind us of both the vastness of the universe and the shared desire to connect. With this enduring hope in mind, we now consider the role of water, a universal solvent and a key ingredient in our search for life beyond Earth. Now turning to the role of water, a universal solvent and the lifeblood of life as we know it, we uncover one of the most critical markers in the search for alien life. Water is not just a substance, it is a foundation, a stage upon which the intricate play of biology unfolds. Its unique properties make it indispensable for supporting life. It dissolves nutrients, facilitates chemical reactions, and transports vital substances within living organisms. On Earth, where there is water, there is life, a pattern so consistent that it has become a guiding principle for astronomers seeking habitable worlds. When scientists study exoplanets, the presence of liquid water is among the first things they look for. This is why the Goldilocks Zone, where temperatures are just right for liquid water to exist, is so crucial. On some of these distant worlds, vast oceans may conceal secrets that have been billions of years in the making, waiting to be discovered. Imagine an alien planet where rivers of liquid water carve winding paths through alien landscapes, nourishing an ecosystem unlike anything we have ever known. Picture vast lakes nestled beneath swirling skies, or icy moons where subterranean oceans lie hidden beneath thick crusts of ice, warmed by the gravitational pull of their host planets. The discovery of water vapor in the atmospheres of exoplanets, as well as evidence of icy bodies and potential oceans within our own solar system, fuels the hope that life might be more common in the universe than we ever imagined. Water does not just signify the possibility of life. It represents a connection, a shared thread between us and these distant worlds, reminding us that the elements which sustain us might also sustain unknown life forms across the cosmos. As we continue to explore these alien realms, water remains our beacon, guiding us in our quest to understand whether we are truly alone or merely one part of a vast, interconnected tapestry of life. With water as our guide, We now look ahead to the future of exoplanet exploration and the infinite possibilities that lie beyond. With the next phase of the journey in sight, humanity's quest to uncover the mysteries of the cosmos is set to enter a groundbreaking era. Upcoming space missions promise to transform our understanding of exoplanets and bring us closer to answering the age-old question, are we alone in the universe? One of the most anticipated advancements lies in the deployment of next-generation telescopes, equipped with technology so advanced they can analyze the atmospheres of distant worlds with an unprecedented level of detail. Missions like the James Webb Space Telescope are already offering glimpses into the depths of space, capturing images and data that reveal the intricate characteristics of exoplanets, its orbiting stars light years away. Following closely is the planned launch of other cutting-edge observatories designed to search for biosignatures, those telltale signs of life, in the atmospheres of potentially habitable planets. Imagine for a moment a telescope capturing the faint glow of a distant world and detecting gases such as oxygen or methane, indicators that life might be thriving beneath alien skies. Beyond telescopes, specialized missions are being developed to probe the hidden secrets of icy moons and explore asteroids that may contain organic materials. These efforts are complemented by groundbreaking artificial intelligence systems, which assist scientists in processing the vast amounts of data collected, uncovering patterns and possibilities that might otherwise go unnoticed. The potential for robotic explorers, equipped to travel to the farthest reaches of our solar system and beyond, is also on the horizon. Imagine a future where spacecraft land on exoplanets, deploying instruments to sample landscapes and analyze soil, water, and air for evidence of life forms that defy our imagination. The collaboration between nations, space agencies, and private enterprises to fund and execute these missions has never been stronger, reflecting humanity's collective desire to unveil the secrets of the cosmos. As we continue to push the limits of technology and scientific understanding, the dream of discovering life on distant worlds feels closer than ever. This relentless pursuit is not just about uncovering alien life, it is about redefining our place in the universe, igniting a shared sense of wonder that unites us all. With every launch, every image, and every discovery, we step further into the vast unknown, guided by curiosity and the hope of finding a connection that transcends the barriers of space and time. As we turn our attention to the ethical implications of alien life, we find ourselves facing questions that challenge the very core of our humanity. What responsibilities would we hold if we were to make contact with an extraterrestrial civilization? Would we approach such an encounter with curiosity and respect, or would fear and misunderstanding dictate our actions? The existence of alien life raises moral considerations about how we engage with beings that may be entirely different from ourselves, yet share the same universe. If these life forms possess intelligence, how would we ensure that our attempts to communicate are free of harm or exploitation? These questions invite us to consider the delicate balance between discovery and stewardship. On Earth, history provides numerous examples of how first contact between civilizations often led to unintended consequences. Could we learn from those lessons and carry them to the stars? Moreover, the discovery of microbial or even more complex life forms on another planet would present its own unique set of challenges. Would we have the right to study and interact with them, or would our obligations lean toward preserving their natural environment, untouched by human interference? Such encounters would compel us to redefine the boundaries of ethics and expand our sense of responsibility beyond Earth. What if alien life is more advanced than us? Could we accept the possibility that we are not the pinnacle of intelligence in the cosmos? And how would that shape our sense of purpose? These are not just scientific questions, but deeply philosophical ones, urging us to reflect on our values and how we see our place in the universe. As we ponder these possibilities, it is worth considering how the discovery of alien life could unite humanity through a shared sense of wonder, inspiring global collaboration and deeper introspection. What might we learn about ourselves through the eyes of another civilization, and how could that understanding reshape our future? These profound questions linger as we continue our search, driving home the truth that the pursuit of alien life is not just about finding others, but also about understanding who we are. Moving forward, let us imagine the extraordinary moment of first contact with alien life. Picture a quiet hum of anticipation as a message from the stars arrives, the culmination of decades of searching and wondering. It could be a sequence of signals, a complex pattern of light, or even an unfamiliar sound carried across the vast distances of space. Whatever form it takes, the realization would be both humbling and profound. Imagine how humanity might pause, united in awe, as we decode the first true whispers from another world. Would the message be a simple greeting, an invitation, or an intricate expression of an entirely different way of understanding existence? Envision the collective response, a surge of curiosity, creativity, and hope as scientists, linguists, and thinkers work together to bridge the immense gap between our worlds. Consider the wonder of unraveling their perspective, discovering insights into their culture, technology, or even their philosophy. This exchange could remind us of the shared beauty of life and the universality of questions that transcend species, like the nature of existence or the desire to understand the cosmos. Imagine the possibilities, from the inspiration to explore new scientific frontiers to fostering a deeper sense of connection among ourselves as we face this cosmic mystery together. In that historic moment, our differences as humans might melt away, replaced by a shared purpose to understand and learn from beings who have traveled their own path through the universe. This encounter would not just answer the question of whether we are alone, but could redefine what it means to be human. It would stretch our imagination, challenge our assumptions, and open our minds to realms of thought we have never considered. What stories might these beings have to tell, and how could their knowledge shape our future? The first contact would be more than an introduction to alien life. It would be a mirror held up to ourselves, reflecting who we are and who we could become. As the sun rises on the final chapter of our journey, let us reflect on the incredible odyssey we have undertaken through the cosmos. From the shimmering oceans of Kepler 22b to the enigmatic skies of TRAPPIST 1e, we have explored worlds that stretch the boundaries of our imagination. These exoplanets, with their potential to harbor life, remind us of the vastness of the universe and the limitless possibilities that reside beyond our own blue planet. Each discovery fuels our curiosity, urging us to look deeper, to dream bigger, and to ask questions that unite us in wonder. The search for alien life is not just about finding other beings. It is a quest to better understand ourselves, our place in the universe, and the fragile beauty of the world we call home. As we gaze into the endless expanse of the cosmos, we are reminded that we are part of something far greater than ourselves. The stars whisper stories of possibilities yet to be uncovered, and their light carries the promise of answers waiting just beyond our reach. So, as you close your eyes tonight, let your thoughts drift to the stars and the mysteries they hold. Let the beauty of the universe fill your dreams and inspire you to wake with a renewed sense of wonder. And if you enjoyed this voyage through the stars, be sure to like this video, subscribe to our channel, and hit the notification bell so you never miss another journey into the cosmos. Together, let us continue to explore, to imagine, and to dream of the infinite possibilities that await us among the stars.